In Lecture 2, we'll explore one set of strategies that can be used to help mitigate climate change, demand-side strategies. In the lecture that follows, we'll explore the challenge of renewable energy, which is the core element of supply-side strategies. This lecture introduces the idea of demand-side mitigation, in contrast to supply-side mitigation. The first component of demand-side mitigation is energy efficiency, which will be illustrated by the example of new advances in vehicle technology and by leading-edge developments in green building practices. Next, we'll explore the other side of the demand-side coin, which is conservation. With a focus more on behavior change here, we'll delve into the issues of residential energy use and transportation demand as ways of illustrating the challenges and opportunities associated with energy conservation. Finally, we'll review these core concepts explored in this lecture before moving on to the supply-side mitigation strategies in the next lecture. Since the combustion of fossil fuels is the main source of anthropogenic or human-caused greenhouse gas emissions, it stands to reason that reducing our consumption of fossil fuels will lessen our impact on the climate. There are two central methods we can use to accomplish this goal of reduced fossil fuel consumption. One is demand-side mitigation, and the other, as we've mentioned, is supply-side mitigation. Demand-side mitigation involves changing our behaviors or our technologies so that we use less fossil fuel, for example, by using a plug-in hybrid vehicle. This type of vehicle still consumes gasoline, but in much smaller quantities than a traditional internal combustion engine. Supply-side mitigation strategies involve exploiting completely new sources of energy in order to reduce our reliance on fossil fuels. This might include producing electricity from wind power rather than from coal-fired power plants. During this lecture, we'll be focusing on demand-side strategies, however, and leave supply-side issues for the lecture that follows. Reduced demand for fossil fuels that produce massive quantities of greenhouse gases can be attained either through energy efficiency or conservation. Energy efficiency just refers to a reduction in the amount of energy we require to perform a particular task, such as to light a room or to transport ourselves from home to work. A really simple formula that we use to understand this is dividing the service provided, such as maintaining a 1,000 square foot home at 20 degrees Celsius for 1 year, by the amount of energy required to provide that service, like 120 gigajoules of natural gas. If we compare that calculation to a home in which we've changed out the furnace, insulated the walls, and taken on these other elements of home efficiency, we now only require 90 gigajoules of natural gas to heat that house, that same house, to the same level over the same period of time. So the first house is obviously less efficient than the second. A variety of opinions exist about the potential for energy efficiency to meet our energy needs in the future and to help mitigate climate change. This short video introduces energy efficiency basics and demonstrates a small set of technologies that can contribute to energy efficiency. While you're watching, I'd like you to consider these questions. Are you convinced that energy efficiency alone is enough to solve our energy supply and climate change problem? And also, where does behavior change fit in, or is this mainly a question of new technologies? Energy efficiency usually increases with wealth, given that financial resources and high levels of education are often required to develop and roll out energy-efficient technologies. Along with wealth, however, has come higher levels of greenhouse gas emissions. In other words, we in North America use less energy per unit GDP than those in South Asia or Sub-Saharan Africa. But our GDP is so high, we consume and produce so much, that the end result is nevertheless high levels of greenhouse gas emissions. As we all know, privately owned and operated vehicles are a core component of culture in many communities around the world. We tend to value freedom, mobility, convenience, and luxury, and these values are bound up in our unparalleled demand for cars. The inevitable peak and then potentially rapid decline of conventional oil supplies, however, as well as the threat of climate change, has intensified the need for modes of personal transportation and mass transit that make better use of increasingly expensive fuel. These more energy-efficient options may be one component of a multi-pronged approach to climate change mitigation that can help reduce air pollution, manage greenhouse gas emissions, and also make our cities more livable spaces. As you saw in the short video earlier in this lecture, a number of strategies can be used to make vehicles more fuel efficient. Lighter materials can be used in their construction, such as lighter composites instead of heavy metals. Improved aerodynamics can help reduce the drag on the vehicle and minimize the work done by the engine. New technologies such as plug-in hybrids could pair cleaner electricity with internal combustion engines that consume traditional fuel, leading to a vehicle that uses significantly less gasoline. Even advanced tires and general vehicle maintenance have also been shown to contribute to significantly higher vehicle efficiency. While the ability of engines to transform fuel into work, such as a car's forward motion, has increased over the last 20 or 30 years, this increase in efficiency has not necessarily translated into decreased fuel consumption by standard North American vehicles. In fact, we've chosen to capitalize on this increasing efficiency by building larger, more powerful vehicles, such as the sport utility vehicle, thereby consuming as much or more fuel as we did with smaller, less fuel-efficient cars. In addition to vehicles, our homes and offices present important opportunities for enhanced energy efficiency and thus climate change mitigation. While older homes are often plagued by design standards that allow the escape of heat and poor use of electricity for light, newer green building standards show dramatic progress towards energy efficiency. Elements of building construction that might contribute to climate change mitigation are the building's location and surroundings, the type of materials used in its construction, the placement of the windows and doors, the color and design of the roof, and of course the devices as well that are used within that building, such as furnaces, lights, and other appliances. While many residential and commercial developments are highly inefficient, we can look to many exciting examples around the world for evidence of evolving best practices in green buildings. Check out this brief video to understand a little more about the core elements of green building and think about what this means for greenhouse gas emissions and ultimately for climate change. It's easy to assume that energy efficiency is mostly about technology. A series of decisions, however, as well as political and cultural factors, figure largely in whether or not we create these technologies in the first place, whether we choose to use them, and whether we continue to use them over time. In other words, energy efficiency is both technological and deeply human. A couple of the factors that influence technological innovation include our culture, like our perception of risk, and our political priorities, policies such as subsidies or taxes, and our technical and financial capacity. Then, a suite of individual decisions matter. Do we associate the new technology with enhanced status or a particular identity that's desirable? Is there infrastructure in place to support our use of the new technology? Do we believe that the switch will benefit us or the environment in some way? Finally, the use of new technology will only be a brief anomaly unless we make its use habit, and governance tools, such as rules and regulations, are put into place to perpetuate its use. Now that we've learned a bit about energy efficiency as a demand-side strategy, let's consider the other side of that coin, conservation. Energy efficiency has a distinctly technological flavor, whereas conservation requires us to use existing technologies or services, but differently or less. Examples of energy-conserving behaviors include turning off the lights, walking instead of driving, and choosing to purchase locally grown food. All of these behaviors face the same cultural and political dimensions that we described in relation to energy efficiency. So it's important to keep in mind that behavior change is a complex and value-based proposition. While the new energy-efficient vehicles we discussed earlier in this lecture inevitably form a portion of the demand-side climate change mitigation picture, there's more to it than this. Other options are clearly available, from cycling and walking to high-speed mass transit and carpooling in some areas. All of these options require shifts in our traditional patterns of behavior and even a rethinking of our core values. Our demand for alternative modes of transportation is heavily influenced by the way our cities are designed, the availability of alternatives, our willingness to explore the potential of car-free lives, and our understanding of the implications of transportation that draw on unsustainable fossil fuels. This is a much more complicated set of factors than replacing an inefficient car with one that performs exactly the same service but using less fuel. So the potential for conservation to contribute meaningfully to climate change mitigation has really been the cause of significant debate. This lecture has introduced us to one of the core sets of climate change mitigation strategies, those that tackle our demand for fossil fuels through energy efficiency and through conservation. While energy efficiency holds great promise in that we may be able to maintain elements of the lifestyle we enjoy today while consuming fewer resources, conservation addresses the important question of shifting our behavior. Together, these two sides of the demand-side coin may contribute meaningfully to climate change mitigation. In the lecture that follows, we'll delve into the topic of supply-side mitigation. In other words, can we find an energy supply that is not fossil fuel-based, and thus will have a much reduced impact on the global climate? We'll explore this and other questions in the next lecture.